SwayamPrabha. Digital India. Educated India.
Dear students, you are welcome in this class. I am Dr. Dinesh Kumar, Principal Scientist from Division of Agronomy, ICAR, Indian Agricultural Research Institute. This lecture pertains to the course Agronomy of Oil, Fiber and Sugar Crops. And the title of the lecture is Origin, History, Spread, Climate, Soil Morphology, Improved Varieties and Cultural Requirement of Safflower. In common language, this safflower is known as kusum. The learning objectives are to describe the origin, history, spread, climate and soil requirement of safflower crop and to explain the morphology, improved varieties and cultural requirement of safflower. Some difficult words in the form of glossary: acute toxicity, quality of substance to cause illness shortly after exposure is acute toxicity, means very severe toxicity. Aggregate of soil, mass of fine soil particle held together by clay, organic matter or microbial gums. So several soil particles are glued by certain organic substances and they make aggregation. Biotic interference, the adverse effect of one organism or population in common ecosystem on another by attracting, encouraging or harboring one or more intermediate organisms. Now, furrow irrigation, method of surface irrigation in which water is supplied to small ditches or furrows and guided across a field. Hard pan, a dense, hard and compacted layer in soil that slows water percolation and movement of air and obstruct root growth. So many times hard pan or hard layer is formed beneath the surface soil and which stops the root growth and also it stops or discourages the percolation of water. Sometimes because of this hard pan there may be water logging in the field which is normally undesirable for safflower crop. So this hard pan is required to be broken by chiseling or by deep plowing, or one can also use disc plow to break this layer. Now moisture tension, it is equal to equivalent pressure that must be applied to soil water to bring it to hydraulic equilibrium through a porous permeable wall with a pool of water of same composition, which is your moisture tension. Mulch, natural or artificial layer of plant residue or other material covering large surface which conserves soil and its moisture and also moderate temperature fluctuations. So many times mulching of the soil is required. It can be done by natural materials like plant residues and it can also be done by plastics and some other material. The basic purpose of mulching is to prevent the losses of water by evaporation, and in addition to that it controls weeds also, and of course it moderates the temperature. If temperature is too low, then it can increase the temperature. If temperature of soil is high, it can decrease the temperature of the soil. So therefore it moderates the temperature of the soil. Surface band, to apply nutrients or soil amendments in narrow bands over the surface of soil. Viruses, many of you might be knowing, non-cellular parasitic pathogens comprised of a protein shell and a simple genetic core, usually RNA in plant viruses. Now you can see the crop of safflower and you can see the color of the flower, bright yellow to orange, and leaves you can see they are spiny. Now we start the importance of safflower crop. So scientific name of safflower is Carthamus tinctorius L. It is cultivated mainly for its seed which is used to get high quality edible oil and bird feed. So there are basically two purposes of growing sunflower. One is to get good quality oil from the seed, and other is it acts as a bird feed. The de-oiled cake or meal is an efficient source of poultry feed and further high value protein hydrolysates and can replace costly soybean protein in the feed industry. Safflower oil is also used in infant foods and liquid nutrition formulations. And dried red and orange flowers, you can see orange and red flowers are sold as substitute for saffron, means it acts as a natural coloring agent, particularly in the Middle East, and are used to color food and beverages can be colored by this material. The seeds are parched and eaten either mixed with wheat or its flour or alone. The flowers are laxative and diaphoretic and are also used in the preparation of cosmetics. Suitably dried flowers are useful to prepare infusions that are helpful in the treatment of many problems, particularly the circulatory system problems, including inflammation and muscular fatigue. Most popular Chinese herbal medicines use safflower petals as one of the ingredients. Safflower petals after pollination are a very valuable source of herbal medicine with high antioxidants in the treatment of many diseases. So they are coloring material and they contain high level of antioxidants. Many of you might be knowing the value of antioxidants. These are the chemicals which clean our blood. Whatever toxic material or waste material are there in our blood, they are cleaned by the antioxidant material. Thus, it improves the health of human beings as well as animals. As an economic activity, to collect petals after pollination can yield 60 to 75 kg petals per hectare, and the market rate of petal is around rupees 800 to 1000 per kg. Safflower as a bird food ingredient has also gained growing acceptance in recent years. So it is used as a poultry feed after fortification with lysine and methionine, and these lysine and methionine are essential amino acid required by the human beings. Decorticated safflower meal has the potential to be used as human food if the bitter principles and phenolics are removed. So decorticated safflower can be used to get the oil. So what can be done? The hulls are removed and that process is decortication. So then the oil content also increases and this material can be used as a food. Safflower leaves are rich in carotene or vitamin A, riboflavin and vitamin C, and hence young seedlings, thinning and prunings are used as green vegetable and as pot herbs. So this is interesting that the leaves, or particularly of the younger seedlings, can be used as a human food. The safflower plant also makes an acceptable livestock forage in times of scarcity if cut at or just after the bloom stage. So in case of exigency, this crop can be used as a forage crop also. Now, after seeing the importance and value of this crop, let us see the origin, history and spread of safflower or kusum crop. So, based on occurrence of closely related wild species, probable origin of cultivated safflower is an area bound by the eastern Mediterranean and Persian Gulf, encompassing southern parts of former USSR, western Iran, Iraq, Syria, southern Turkey, Jordan and Israel. So it has got spread over a wide area. Western expansion of the Arabs or Arabic people in creating the Muslim empire of the 5th and 6th centuries probably expanded safflower cultivation along the Maghreb and into Europe via the Iberian Peninsula. Introduced into Britain from Egypt in 1551. Safflower was grown by monks and in private herb gardens not only as a pot herb but also as a dyeing material. In Gloucestershire, such large quantities of flowers were used to color sausages and cheese that it had a considerable purgative effect. It can be mixed with French chalk and it forms cosmetic rogue. Retained in the European pharmacopoeia until recently, and it was seldom prescribed as a specific remedy. Now we can see the world area, production and productivity of safflower crop. In the first column you can see there are different years: 1961, 71, 81, 91, 2001, 11, 19 and 20. And you can see the area, how the trend happened in the area in million hectare. So in 1961 it was 0.76 million hectare, and then which continued to increase till 1981 when it became 1.29 million hectare, and then there was a fall or decrease in area. So you can see by and large the area decreased to 0.82 million hectare. That means currently in year 2020 the area of safflower at world level was 0.82 million hectare. Coming to the production trend, there is no any fixed trend, and you can see in 1961 production was 0.33 million tons, which increased to 9.9 million tons in 1971, and then it starts falling, and you can see almost fell down to 0.65, which was 0.9 million tons in 1971, you can see here, and then it has fallen down to 0.65 million ton in 2020. That means a slight increase in area is there and slight decrease in area is there, and also there is decrease in the production of this crop. And coming to the productivity, productivity of course has increased over the years. In year 1961 it was 431 kilogram per hectare, and which increased to or almost doubled in 1971 in 10 years period, 806 kilogram per hectare, and then again it started falling, and in 1991 it fell down to 530 kilogram seed per hectare, and then again increase happened and here and there, and finally you can say the productivity of safflower in the world is 799, or you can say 800 kilogram seed per hectare of safflower. Coming to the distribution in different countries or nations producing safflower during 2020. This data pertains to year 2020 and it is taken from FAO Stat, Food and Agriculture Organization, Rome, Italy. The data has been procured from that source. So now you can see Kazakhstan. Kazakhstan has the highest area of safflower in 2020, which is 0.315 million hectare, followed by Russian Federation 0.175 million hectare, and then India has 0.085 million hectare. Next is USA 0.051 million hectare, Mexico 0.050 million hectare. Coming to production, you can see here Kazakhstan has highest production in the world, 0.227 million ton, and followed by Russian Federation, which has about 0.097 million ton, and then Mexico 0.087 million ton, and then USA 0.067, and India 0.044 million tons. So you can see these are the 5 important countries growing safflower in the world. Coming to the productivity, you can check the last column of this table. In Mexico, you can see it is highest productivity, 1,721 kilogram per hectare, which is almost 3 times more than what we have in India or in Russia. You can see Russian Federation. In Russian Federation, it is 552 kg per hectare. In India, it is only 514 kilogram per hectare. Kazakhstan has 719 kilogram per hectare of the productivity. So main message here is that Kazakhstan has highest area, which is 0.315 million hectare, and also highest production is in Kazakhstan, which is 0.227 million ton, and so far productivity is concerned, it is highest in Mexico among the countries here. Now area, production and yield of safflower in India. So you can see what kind of trend is happening in India. In 1971-72, it was 0.598 million hectare area, which increased to 0.748 in 1981-82. And then there is fall in the area, almost continuous fall in the area. And you can see in the year, the current year, 2022-23, the highest area of safflower in India was 0.109, or area in India was 0.109 million hectare. So you can see the situation of this crop is really not good. And coming to production, the production in 1971-72 was 0.13 million tons, and which has increased to 0.422 million tons in 1981-82. And then from here onward, you can see fall is happening, and at present in year 2022-23, the production of safflower in India was 0.09 million tons, or you can say 0.1 million tons, which is really a matter of worry. So far productivity is concerned, you can check in the last column, productivity is continuously increasing in the country, and you can see it was in 1971-72 218 kilogram per hectare seed, and which increased to 563 in 81-82, more than 2 times jump in productivity of safflower during these 10 years. And then again there was a fall or decrease, and then it further increased, and finally you can see among all these years the highest productivity was achieved in 22-23, which is 826 kilogram per hectare. So far productivity is concerned, it is increasing in the country. Now see 5 important states producing safflower in 22-23. So in this case Karnataka tops the list, and which has 0.062 million hectare area, and it also has the highest production, 0.056 million ton. Next important state is Maharashtra, so far safflower is concerned, and it grows on 0.032 million hectare area with a production of 0.023 million tons. And then Telangana, Andhra Pradesh and Odisha are another states which are growing safflower. As you have seen, the highest production was in Karnataka, and it was followed by Maharashtra and then Telangana. Coming to productivity, you can see the last column, the highest productivity is observed in Telangana, which is about 900 kilogram per hectare, and it is closely followed by Karnataka. It is having about 896 kilogram seed of safflower per hectare. And then other states like Maharashtra has 715 kilogram per hectare seed production, per hectare seed productivity, and Andhra Pradesh has 572 and Odisha has 625. So overall, from this table we can conclude that Karnataka state has highest area and as well as highest production, and Telangana has highest productivity followed by Karnataka. Now taxonomy or classification of this crop. So cultivated safflower may have its origin from 2 related species of wild safflower, that is Carthamus oxycanthus from Afghanistan and adjoining countries like Pakistan, and from saffron thistle. Saffron thistle is another species, Carthamus lanatus from Ethiopia. So you can see there can be 2 wild ancestors. One is Carthamus oxycanthus, other is Carthamus lanatus. A botanical classification for safflower in both Latin and English as given by the USDA is, so safflower belongs to kingdom Plantae, that is plants, and subkingdom is Trachobionta, vascular plants. Superdivision is Spermatophyta, means seed bearing plants. Division is Magnoliophyta, means flowering plants, and class is Magnoliopsida, means dicotyledonous, and subclass is Asteridae, order is Asterales, and family is Asteraceae or aster family, to which sunflower also belong. and genus is Carthamus, and species of course Tinctorius, cultivated species. So genus Carthamus contains about 25 wild species distributed from Spain, North America and West Asia and to India. So it has very wide distribution across the globe. Many are indigenous to the Mediterranean region, but only one, Carthamus tinctorius, is the cultivated species and which is usually cultivated for commercial purposes. Now, dear students, we can switch over to next subject of the lecture, which is morphology. Morphology means external appearance of a plant, how it looks from outside. So, we will see the appearance of root, stem, leaf, flower, fruit and seed one by one. So, safflower is an erect herbaceous. Herbaceous means it does not have wood. Highly branched, spiny, thistle-like annual plant that grows from 30 to 150 centimeter height. So, lot of variation exists in the height of the plant and branching is also there, unlike sunflower. So, young safflower plants form a rosette. Rosette means kind of very vegetative and dense vegetation and remain in this vegetative state for many weeks, during which leaves and deep taproot system develop. So, it has very well defined and deep taproot system. Now, coming to the root, so plant has a well defined fleshy taproot. So, you can see on the right side in the picture, the taproot is quite fleshy. This is taproot and you can also see it is going very deep in the soil. So, it also got numerous thin and horizontal lateral roots that penetrate up to 1.5 to 3 meter. So, that is why it is highly drought tolerant plant. So, you can see the laterals are there, lateral roots are there. Here lateral means lateral roots and they are horizontally to the surface. So, deep taproot system with abundant thin horizontal roots allows plant to extract water and nutrients from the deeper layers. So, such kind of roots are more deeper than the sunflower roots. See one very close up of the safflower roots here. You can see it is fleshy and it is going very deep into the soil, and you can also see the horizontal these laterals or lateral roots, they are very fine. Of course, the main taproot is very thick, but if you see the laterals or these primary roots or then secondary roots, they are very thin and they indicate that they can extract water and nutrients more efficiently than the thick roots. Now, stem and branching. So, stiff, cylindrical, fairy, thick at base, this is about the stem, becoming thinner as height increases. Quite smooth, glabrous, with high grey to green to white within fine longitudinal grooves and becoming brittle when mature. So, on maturity it becomes weak and it can easily break down. So, lateral branches develop on stems. So, this is interesting that branching happens in this crop that are about 20 to 40 centimeter high, and these lateral branches may produce secondary and tertiary branches, and more branches give higher seed yield as each branch ends in a flower head. So, you will have many flower heads on one plant, unlike sunflower where normally you have one head. So, now you can see in this picture branching pattern and this is the main stem you can see, and from this you can see the branches are coming out, and at the end of each branch you get one head or capitulum you can see here, there also. So, this is how the branching happens in safflower crop. Now, leaf. So, leaf size and shape vary considerably between a variety and individual plants. They are about 2.5 to 5 centimeter broad and 10 to 15 centimeter long and usually large and deeply serrated on the lower stem. Leaf short and stiff, ovate to obovate at the inflorescence, means these are the kind of shapes of leaf, whether it is ovate or it can be obovate. When they become superimposed as the involucre bracts. Now you can see the picture of leaves in a close-up here. Now flower. The inflorescence consists of numerous florets collected closely together on a circular, somewhat flattened receptacle. So one receptacle is there which collects numerous florets. The number of florets varies from 20 to 200 with the variety and is also influenced by the environment. So these two factors influence the number of florets, particularly genetics and also the environmental or management factor affect this. The receptacle is surrounded by several layers of involucre bracts, the outer ring being heavily spined. Individual flowers are themselves provided with bracts in the form of small hairs. The involucre is conical with a small apical opening through which corolla tubes of the flowers protrude. Flower color can vary from whitish yellow to red orange or deep yellow being the most common. So you can see here it is mostly deep yellow color is there with some red color. Capitula are borne at the end of stem or branches. So this capitula would have flowers. The one of the main branch blooms before those on the secondary branches. Flower heads can vary in diameter from 1.25 to 4 centimeter and their number per plant varies from 5 to 60 or more. Within a capitulum, flowering begins in the outer circle of florets and progresses centripetally towards the center of the capitulum over several days up to a week. The total bloom stage may last for 4 weeks or more. Now you can see the structure of the flower. Here botanical illustration of a safflower branch. So number 1 is branched stem. This is your branch number 1 and this is your branched stem. Branching is there on the stem. Here of course one branch is there, but there can be many branches on this plant. Number 2 is sessile leaves, means leaves do not have petiole. If leaves do not have petiole, then they are called as sessile leaves and they grow in alternate fashion. So you can see on this particular plant, suppose this leaf is on this side, another will be on this side and then this side, this side. So they are in alternate arrangement. Inflorescence is number 3. Number 3 is here. So this is your inflorescence and numerous flowers on the inflorescence. So these are your actually flowers and each is your floret. Now see the structure of the flower. So this is cross section of inflorescence. Number 1, this one is 7 days before blooming. Blooming means flowering. This is number 2. Then there is development of florets. This is 3 days before blooming. The third one is bloom day. This is the bloom day and fourth one is 3 days after the blooming, this one. And on the right side you can see different developmental stages of petals, how petal develops. The time to flower in a variety is genetically controlled but can greatly influenced by the environment also. Seed mass increases rapidly during the first 15 days after flowering. Seeds mature in 4 to 5 weeks from flowering. This is very important point to note that the seed mature in this crop 4 to 5 weeks after flowering. Now fruits and seeds. The fruit is called as achene, resembles a small, slightly rectangular sunflower seed, but with a thicker, more fibrous hull. Pappus is normally absent, but may occur in some seeds, and these are normally from the center of the flower head. The testa is generally cream or white or off-white color, but gray and mottled types may also occur. Seed size is a varietal characteristics, variable and is affected by climatic conditions. So it is important to note that Seed size is normally a genetic character controlled by the genes or genetics of the crop, but it is also influenced by the management or agronomic factors. So, both these factors determine the seed size, and however, the variety will remain same, and if it is grown in different environments and under different management conditions, so seed weight will vary. The seeds are 4 to 9 millimeter long and above half as broad, with 100 seed weighing 2.5 to 8 gram. Depending on the cultivar and head position, cultivated safflower produces 20 to over 100 developed seed in each head. The proportion of hull can vary from 30 to 64%. Now, you can see the color of the seeds here, off-white, white or kind of creamy color. Of white color, you can see off-white color. So, different shades of the color are there. Now, coming to the climatic requirement, what kind of rainfall is required by this crop? Can it tolerate waterlogging? What kind of temperatures are needed for its vegetative growth or reproductive growth? Those are climatic requirements. So, it shows wide adaptability with certain geographical limits and may grow from mountains of Afghanistan to plains of Ganges and Nile valleys. So, really it has got very wider adaptability. Globally, safflower cultivation is within latitudes of 35 degrees south to 45 degrees north on the globe. In India, it is mostly cultivated between 14 degree and 22 degree north and 73 degree and 79 degree east longitude during the Rabi season. Normally grown at less than 900 to 1000 meter altitude above the mean sea level, and both seed yield and oil content fall with increasing altitude. If we increase the altitude of cultivation of this crop, then there is decrease in the oil content and the yield of the crop for the same variety. So, altitude also affects the rate of growth, and maximum height of a given variety may be 25% higher when grown below 300 meter than at 900 meter. Means lower the altitude, higher is the plant height. Safflower can be a promising alternative crop in dryland agroecosystems due to its growth potential under the water stress. So, it is really a good crop and it can succeed very well under rainfall scanty situations. It is considered to be a day neutral, but varieties may show adaptation to a specific photoperiod when grown at limits of their normal range. So, by and large, safflower crop is a day neutral. Its flowering and fruiting is least affected by the photoperiod or length of the day. A short photoperiod can prolong the rosette stage, means more vegetative stage. Temperature is more important than the day length in this crop. So, good yields have been obtained in plants' natural habitat with varying day length. It is thermosensitive, means it is quite susceptible or sensitive to the temperature and does not favor extremes of either heat or cold. Seedling stage is more tolerant of low temperature. So, cooler temperatures are fine, but too low or low temperatures are not good for this crop. Similarly, too high or extremes of temperatures are undesirable, are not fitting to this crop. A temperature of about 15 degrees centigrade is highly favorable for rapid germination, while a mean temperature of 20 to 21 degrees centigrade favors the optimum growth. So, you can see the temperature range for optimum growth is quite narrow, which is 20 to 21 degrees centigrade. Effect of high temperature on safflower appears to be most severe at flowering. Particularly at higher temperature, there may be problem with the germination of the pollen, or pollen mortality can happen at very high temperature. So, high temperature also reduces the rate of dry matter accumulation, and it shortens the period between flowering on the main stem and subsequent branching. Higher temperature also reduces the period of flowering, size of flowers are reduced, seed setting is reduced, and in the end 100 seed weight of the safflower plant is also reduced. So you are seeing it is having very adverse effect on growth as well as many yield attributes of the safflower crop. At flowering, a day temperature of 24 to 32 degrees centigrade is congenial for obtaining higher yields. It is a drought resistant crop capable of obtaining moisture from levels not available to the majority of the crops. And as already discussed, that it is because of the roots. Its roots go very deep and it has several lateral roots which are capable of extracting moisture. Climatic conditions during growth will affect the total moisture requirement and maturity of the crop. In hot, dry wind areas and with adequate pre-planting soil moisture, 300 mm of rain will produce excellent yields if this falls prior to flowering. So you can see the water requirement or rainfall requirement of this crop is quite low. In India, a rainfall of 650 to 1000 mm is considered optimum. Prolonged rainfall at flowering adversely affects the pollination because of there may be some washing of the pollens, so it affects the seed setting. When heads are mature, persistent rain encourages seeds to germinate in the head. Then the quality and yield of the crop will be affected. So in general, there should not be any rainfall during flowering stage or seed maturation stage. We can expect. Crop cannot tolerate excess moisture or waterlogging at any stage. Excessive humidity during any stage of growth increases damage from the fungal diseases. So if you have more humidity around or in the microclimate, then it attracts fungal growth or it attracts fungal multiplication. Therefore, certain diseases can come to the crop. In areas where foggy or misty period occurs during flowering, head rots can be damaging. The fully grown plant is extremely wind resistant, and even after seeds are mature, there are few losses from lodging or shattering. So this is a positive point for this crop, that lodging is not quite common in this crop and shattering is also not there. So therefore, it is a kind of good characteristic of this crop. Now after climatic requirement, let us see what kind of soils are required for the cultivation of safflower crop. So safflower requires fertile, fairly deep and well drained soils with a pH of 5 to 8. The range of pH is 5 to 8. So you can see it, the range of pH is quite wide. Irrespective of their fertility, shallow soils seldom produce high yields due to insufficient moisture. So there has to be some deep soils. Dense subsoil or layer of impermeable clay retards root growth, and yields from the rain-fed or protective irrigated crop are substantially reduced. Shallow sandy soils are again not suitable for safflower, and again one problem could be waterlogging, and it does not tolerate waterlogging. Therefore, the soils which do not have waterlogging problem should be preferred for the cultivation of the safflower. Heavy soils with poor drainage must also be avoided for growing safflower, especially under irrigation. In traditional safflower areas in India, particularly say Maharashtra and Karnataka, safflower is grown on black cotton soils or vertizoes. In other states, it is cultivated on sandy loams to clay loams, particularly of the order alphizoles, antizoles and altizoles, both under irrigated as well as rain-fed conditions. On heavy soils, it can follow an early kharif crop or may often be the single crop of Rabi season. On lighter soils, it is almost entirely irrigated and may be strip cropped with cereal or legume. Some kind of strip cropping can be done with this crop. Safflower is considered to be salt tolerant, ranking just below cotton in ability to produce profitable yields when grown on saline soils. It is especially tolerant to sodium salts, but less tolerant to calcium and magnesium salts. There is a significant varietal difference in salinity tolerance of safflower. Salinity reduces seed size and oil content. Safflower has remarkable ability for adapting to salinity through differential nutrient uptake and accumulation of major and secondary nutrients, resulting in low yield loss. Now, after the soil requirement, let us see cropping systems. So, of course, there are two kinds of cropping system. One is sequential cropping system, where safflower is grown under different rotations, and these rotations can be for 1 year, 2 years or 3 years. Normally, they should be for longer period, and also it can be fitted under intercropping systems. So, we will see now what are the sequential cropping system as well as intercropping systems for growing this crop. So, in sequential cropping systems, a number of productive and remunerative cereal legume safflower sequences are identified for various agro-ecoregions of the country. Further, continuous cropping of safflower encourages buildup of fungal diseases like wilts, root rots, besides adversely affecting the long-term soil productivity, and hence should be avoided. So, overall you can see monoculture of this crop means growing safflower crop year after year in the same field will result in buildup of certain diseases and also insect pests. Therefore, proper crop rotations should be followed. Safflower should be rotated with prevailing kharif or rabi crops in the region without any fear or inhibition. The inclusion of grain legume in the rotation should be preferred, as it not only benefits safflower but also improves soil fertility. So, grain legume can be your leguminous crops like your groundnut. The promising rotations are given in next slides. So, you can see some promising rotations for different regions. Transitional tracts of Karnataka, mung bean safflower and groundnut safflower. For scanty rainfall areas of Karnataka, mung bean safflower, hybrid sorghum safflower, and then Setaria safflower. For northern Telangana, mung bean safflower, maize safflower. This means this maize and mung bean is being grown during kharif season and safflower is taken during rabi season. So, maize safflower, and then hybrid sorghum safflower and sesame safflower. So, sesame is again an oilseed crop. Assured moisture areas of Maharashtra. So, there are number of choices: mung bean safflower, urd bean safflower, hybrid sorghum safflower, groundnut safflower, sesame safflower, sunflower safflower, soya bean and safflower. Drought prone areas of Maharashtra, you can see mung bean safflower and urd bean safflower. Malwa plateau of Madhya Pradesh, soya bean safflower, maize safflower, groundnut safflower. And coming to Bundelkhand region of UP, cowpea safflower and mung bean safflower. Plateau region of Bihar, upland rice during kharif season or rainy season, and in rabi season safflower. Hybrid palmlet safflower, mung bean safflower, urd bean safflower, and again sesame safflower. So, it can be grown after the cereal, it can be grown after the pulses or oilseed crops. Now, let us see some intercropping system which has been recommended or adopted. So, you see different regions are there and suggested intercropping system, and row proportion means intercrop is to safflower. So, in this case, suppose for Andhra Pradesh you have chickpea plus safflower 3:1 or 2:1 ratio. 3:1 means 3 rows of chickpea and 1 row of safflower. 2:1 means 2 rows of chickpea and 1 row of safflower. Then again wheat plus safflower 3:1 or 2:1. Then coriander plus safflower 3:1 or 2:1. Linseed plus safflower 3:1 or 2:1. Coming to Karnataka, what are the intercropping systems? Chickpea plus safflower in the ratio of 3:1. coriander plus safflower 3:1 or 2:1, and wheat plus safflower 3:1 or 5:1. Now for Madhya Pradesh or Chhattisgarh, you can see suggested intercropping systems, and in the last column you can see raw proportion of intercrop is to safflower. So here for Madhya Pradesh or Chhattisgarh, you can see chickpea plus safflower in the ratio, raw ratio of 6:2 or 4:2 or 2:1. I hope students get the meaning of this. 6:2 means 6 rows of chickpea and 2 rows of safflower. Similarly, 4:2 means 4 rows of chickpea and 2 rows of safflower, or 2:1 means 2 rows of chickpea and 1 row of safflower. Now linseed plus safflower 6:2 or 2:1 ratio, amaranthus plus safflower 6:2, thoria plus safflower 6:2, mustard plus safflower 6:2. So question comes, why we are going for intercropping system? So actually there are several benefits of growing crops as intercrop. So in this case the space is used more effectively, and one can have legume crop with the cereal crops or oilseed crop with the legume crop. In that case, there may be some nitrogen fixation also, and it has been observed very clearly that intercropping systems in general reduces insect pest and disease damage to both the crops. So therefore, both are benefited, and also under vagaries or of monsoon or certain climatic conditions, if one crop is damaged, then farmers will get income from the other. So these are the main purposes of having intercropping systems. So now you see next intercropping systems for Maharashtra. You can have chickpea, which is a legume, plus safflower 3:1 or 2:1. Then you can have wheat plus safflower 3:1 or 2:1. Linseed plus safflower 3:1 or 2:1, and coriander plus safflower 3:1. So again 3:1 means 3 rows of coriander and 1 row of safflower. For Uttar Pradesh, Eastern and Bundelkhand region, Eastern UP and Bundelkhand region, the suggested intercropping systems are linseed plus safflower in the ratio of 3:1, chickpea plus safflower in the ratio of 3:1, and barley plus safflower ratio 6:2 means 6 rows of barley and 2 rows of safflower, and thoria plus safflower 1:2, 1 row of thoria and 2 rows of safflower. So this thoria is basically member of the rapeseed, you can call it, in the group of rapeseed and mustard crops. Let us see the varieties of safflower crop, and of course it has varieties as well as certain hybrids are there. In general, the yield potential of hybrids is more, and hybrids are preferred by the farmers. The only limitation with hybrid is that you need to have fresh seed every time you are going for sowing. However, variety seed can be used for many years by the farmers. So let us see what are different varieties and hybrid of this crop and their year of release and recommended zone where they have been recommended. First one is NARI 6. It is a variety. In the bracket you see V. V is for variety. Year of release 2001, and it is recommended for the all India, means whole country. It can be grown anywhere in the regions. NARI NH1. It is a hybrid and it was released in 2002, and it is for the whole country. All India means here whole country it can be grown. Phule Kusum, it is a variety released in 2005 and recommended for all India or whole country. JSI 97, it is a variety released in 2005 and it is recommended for Madhya Pradesh and Chhattisgarh states. Then NARIH-15, it is a hybrid released in 2006 and it is recommended for whole country. JSI 99, a variety, it was released in 2006 and it is recommended for Madhya Pradesh and Chhattisgarh. Next is Parbhani Kusuma, it is a variety. It was released in year 2007 and it is recommended for cultivation in Maharashtra. Then PBNS-40, it is a variety released in 2007 and it is for all India or you can say whole country. Then AKS-207, it is variety released in 2007 and it is recommended for Vidarbha region of Maharashtra state. Then SSF-708, a variety released in 2012 and recommended for western Maharashtra. Then PKV Pink, it is a variety, 2013 it was released and it is recommended for cultivation in Vidarbha region of Maharashtra. NARI-H-23, it is a hybrid. It was released in year 2014 and it is recommended for cultivation in the states of Maharashtra, Karnataka, Madhya Pradesh, Chhattisgarh, Rajasthan and West Bengal. NARI-57, it is a variety released in 2015, recommended for Maharashtra, Karnataka, Madhya Pradesh, West Bengal, Rajasthan, UP, Punjab and Jharkhand. Next variety is your NARI-96 or NARI-96. It was released in year 2018 and recommended for cultivation in the states of Maharashtra, Telangana, Andhra Pradesh, Madhya Pradesh, Chhattisgarh and Rajasthan. The next is hybrid. It is quite a good hybrid, DSH-185. It was released in 2018 and it was released for cultivation in whole country. Means wherever cultivation of safflower is done in the country, this particular hybrid can be grown. Then PBNS-86, it is a variety. It was released in year 2018 and this particular variety is recommended for the state of Maharashtra. Next is ISF-764, a variety released in 2019 or 2019 and it is again recommended for all India or whole country or all areas of the sunflower growing in the country. As ISF-1, it is a variety 2019 all India or whole country, and then one more variety is there which is SSF-12-40. This particular variety was released in 2019 in the country and the areas where it is recommended for cultivation are states of Maharashtra, Karnataka and Telangana, which is making zone 1 for cultivation of safflower. Now we go to the land preparation for the cultivation of safflower. The first important thing is that for any crop, whether it is safflower, sunflower or any other crop, you have to have right moisture at the time of germination or at the time of sowing. If we do not have good moisture at the time of sowing or germination, germination will not happen and you will not get the right plant stand. There may be shortage or less plant population which will result in poor seed yields. So therefore, right moisture has to be there at the time of sowing of this crop. So safflower requires a clod-free seed bed but not so fine that may lead to crust formation after rain. If the fields are infested with obnoxious weeds, deep plowing is recommended during the summer. In areas where safflower is taken as an intercrop, the land prepared for the main crop is good enough for safflower also. Now you see optimum time of sowing for different regions. For Andhra Pradesh, coastal and Rayalaseema region, the recommended sowing time is October. So here you can see it is being grown mostly as a rabi crop. Then in Telangana, late September to early October. This is the right time of sowing for safflower. For Bihar, the second week of October is the right time of sowing of this crop. For Karnataka, under rain-fed conditions, second fortnight of September is the right time of sowing. And for irrigated conditions of Karnataka, it is mid-September to early November. So you can see how the sowing times are varying from region to region and from situation to situation. Now for Madhya Pradesh, particularly in Malwa Plateau, the right time of sowing is last week of September to first week of October. For Chhattisgarh state, second week of October to second week of November is the right time. So it is necessary to do sowing of any crop at the right time of sowing. If we are unable to do it, then we cannot get the better plant population, we cannot get good crop growth also. For Maharashtra, drought-prone areas of western Maharashtra, the second fortnight of September is the ideal time. For assured rainfall areas of western Maharashtra, last week of September to mid-October. So this is how sowing time varies. For Odisha, the optimum time of sowing is second week of September to middle October. Rajasthan, early to mid-October. Tamil Nadu, early to mid-October. For Uttar Pradesh, two conditions are there. One is rain-fed and other is irrigated. For rain-fed, second to third week of October in Uttar Pradesh, and for irrigated condition, mid-October to the first week of November. Now, it is necessary before sowing for pre-soaking and seed treatment. Pre-sowing seed hardening of safflower induces drought tolerance, so it becomes necessary. For eastern Chhattisgarh, it has been recommended to pre-soak the seeds in pure water for 24 to 48 hours and shade dry for about 4 hours. Thereafter, seed must be treated with fungicide like Thiram, Captan or Bavastine at the rate of 3 gram per kg seed before sowing. So if we are treating the seed with fungicide, so we can save our crop from many fungal diseases at a later stage. So you can see optimum seed rate and spacing for different regions. Andhra Pradesh seed rate is 7.5 to 10 kg per hectare, spacing is 45 into 20. So for most of the situation you can see spacing is 45 into 20, and seed rate for Bihar and UP, for example, 12 to 15 kg per hectare under adequate moisture. If moisture is less, then you need to increase the seed rate. For Gujarat, 10 to 15 kg per hectare. Karnataka seed rate is 7.5 kg per hectare. Spacing is 60 by 30. For Madhya Pradesh, 20 kg per hectare, and spacing is 45 into 20 to 25. So likewise, you find different seed rates and optimum spacing for different regions. And sowing method is concerned, optimum depth of sowing is 5 centimeter. The border method of planting, in which one row is skipped, is a good method. And for better stand, line sowing using improved seed drill or fertilizer cum seed drill should be followed. Seeds can be sown behind the desi plough also, and single row dryland deep furrow seeder are also available. So leaving the surface fluffy, light planking is recommended. So overall, if we go for by right method of sowing, we can have a good germination of the crop. Dear student, hope you enjoyed this lecture. Thank you very much.